I'll go over the practice for IP version 6. I'm gonna cover what is duplicate address detection, the router salutation, and the router advertisement. Also, I'll cover what are the different addresses that comes with IP version 6, and I'm gonna cover the commands we need to use for this assignment. So let's go ahead and configure this topology. So I already went ahead and I connected these routers, and so we just need to configure them. Also, I started Wireshark between router 1 and router 2. So let's look at what commands we need to use. Okay, so with router 1 we need to manually configure it, but router 2 is gonna auto configure itself. That means we're gonna assign the address ourselves to router 1, but router 2 is gonna assign an address to itself by itself. Okay, so we have we need to type this command. We already did. So let's go ahead and assign an IP version 6 at this interface 0. um, I'm not gonna use the same address we have in the practice. So if you remember, with IP version 6, the upper 64 is used for the network and the subnet ID, and the lower 64 is used for the interface ID. So we're not gonna assign the lower 64 ourselves. Instead, we're gonna make the router assign it to itself, and we will use what's called the extended unique identifier. And there is a link in the practice that shows how the router used its MAC address to assign itself the interface ID. So let's look, as I mentioned before, IP version 6 assigned different addresses to each device in the network. So let's look how many addresses we have, and we're going to use each one of them. So by typing the command show IP version 6 interface, we can see the different addresses we have at interface 00. So we have here the link local address, and if you remember in the class, we don't have ARP request and reply anymore in IP version 6. Instead, we use this address to communicate with devices inside the network. We use this address to communicate with devices outside the network, so it is routable. Also, we have different multicast group. When a router is active in the network, it will join all these 3 groups. So the first one is for all nodes in the network. The second one is for all routers in the network. So if a PC wants to communicate with a router, it needs to use this multicast address, or it will use the link local address to communicate with it. Also, we have the link local multicast address, and this is used most of the time with a neighbor salutation. So now we have 2 active addresses, the link local address and the global unicast address, which are unique in the network. So let's look what kind of messages we have after we assign these addresses to router 1. So we have the neighbor salutation. We can see neighbor salutation and neighbor advertisement messages, and we can see 2 neighbor salutation. So this is what is the duplicate address detection do. It will issue a neighbor salutation message for the link local address. So before this link local address become active at router 1 will issue a router salutation message for this router. If one reply to this message, that means this message is not unique. But this address is not unique. I'm sorry. So the source of the address will be anonymous, and the destination will be the link local multicast group. And the link local multicast group use the lower 24 bits from the interface ID. If you can see, they are the same, right? These are the lower 24 bits. So the neighbor salutation, it's like the ARP request in IP version 4. It will ask who has this IP address, and the ARP will apply with the MAC address for that IP. So the ARP request here is like ARP request who has this link local address. You can see it in the target address. The person who's going to reply is router 1 itself, but the destination will be the multicast group for all nodes in the network. Like I showed you before, that this multicast group is for all nodes in the network. Everyone in this multicast group is going to receive it. And as I mentioned, this is like the ARP reply, so it will reply back that I'm this device with this MAC address, and the MAC address is the same as router 1 MAC address. That means this address is unique. So now we know that our link local address is unique. Now we need to see if our global address is unique too. So we're gonna do the same process again, and the reply will be the target address, which is the global address with its MAC address. And if you remember, routers in the network with IPv6, they send router advertisement periodically. That's mean every period. They're gonna send to the all nodes in the network, as I mentioned before, and they will send these information: the maximum transmission units, their MAC address, and the prefix information for this network. So this is what's all the how the duplicate address detection works. So let's go ahead and configure router 2. Actually, we're gonna make it auto configure itself. So we're gonna use IPv6 unicast routing and interface 00. And we're gonna type IPv6. Okay, this address auto configure. That means we don't have to configure router 2. It's gonna auto configure itself. And no shot. Okay. So, we did not start Wireshark, but it's gonna be this is part of the lab assignment, so I think it's a good thing that I didn't show it. Okay, join interface. Okay, so as I mentioned, this is the link local address. So let's close this. Okay, so this is the link local address. And uses these bits to it uses the its MAC address to assign itself the lower 64 bits, the interface ID number, right? We have the same multicast group, right? And it assigns itself the global address, and this is happened by using the information the sent by router 1, the router advertisement. So let's also auto configure this device. So we just have to type IP auto. But okay, let's go ahead and see what kind of messages that we're gonna see. Okay, let's do again. Oh, okay, I see what's the problem here. If you can see here, when we do IP auto, that means this device needs to get it needs to assign itself an address using the router advertisement, and um, and what this device needs to do is need to do a router salutation. And as I mentioned before, this multicast group is only for the routers. So any router in this multicast group will reply back with a router advertisement that contain all the necessary information for this device to assign itself an IP address. And the problem is just because we did not configure this interface. So let's go ahead and configure interface 1. Okay. So we're gonna use different address for this network. And of course this interface cannot auto configure itself, because it's the first device in this network. Let's call it subnet B. That's why we have to configure it ourselves. So if you can see here, the same process that happened when router 1 assigned itself an address is happening again with router 2. The neighbor salutation, the duplicate address detection for both the link local address and the global address. So let's go ahead and type IP auto, and what's gonna happen is that this device is gonna issue a router salutation to ask for a router advertisement, and router 2 will answer back. Okay, so here is a router salutation, and the destination is for all devices in the network. And I think what happened is that this device already used the information already published from the router advertisement, from this message, to assign itself an address. That's why we have a source with an address, comparing before we do not have anything. So let's see what information the router sent in its network. So it will contain the maximum transmission unit, the MAC address, and the prefix information. And this is basically how the duplicate address detection work, and how the router, what is the use for router salutation. When we when a new device joins the network and need information about this network, it will issue a router salutation, and a router advertisement will be sent back by one of the routers. Okay, this is the first part of the lab. The second part, the only difference is that you have to configure one of these devices, which is PC1, to act as a router. And this is you can do this by enabling these by following these steps. So you only need to do these on PC1. You only enable the forwarding on PC1. That's mean you don't need to do it again on PC2, because PC2 is not acting as a router. Just remember that in your assignment. So here we have it as set up as but I don't think you need to oh, this one. You don't need to apply this one as on PC2. You only need to do it on PC1. Good luck.